Thank you. I will in Spanish. I'll speak English. Sorry, my Italian is... I think I can understand everything, but I won't be able to, it will be too embarrassing. So, thank you, Maria Grazia and Sabrina and the whole team. I think I've been here for 2 hours with you, and I think I see the vision. I see the vision of creating community, creating culture, the importance of doing that through innovation, cultural innovation, not just technological innovation, but also to contribute with this vision to create new imaginations, new imaginaries. And I think I can say something about this. So I'm going to start. I think I left my... this one, but also this thing. This is the essential thing. So I'm going to start by, well, it's important for you to know that I'm an art historian and I'm not a scientist. And as an art historian, I like to tell stories. So bear with me, because the stories will be told through images that you probably don't connect with CERN, but they are important in the construction of a laboratory as CERN, but also the construction of the contemporary science. And so my first provocation is these images, the story that I'm going to go back to the 20th century and how slowly science became what we know today about science. I'm going to explain and try to explain during these 40 minutes what is CERN, what it means to me, to the artist, but also to society and to its own community. And but overall, what is happening today is very important, and I'll stop with this question. I'll start. So how can we describe reality today without considering the rapid scientific and technological developments? And how artists are posing questions that are very relevant to us today, and that are questioning this reality that is described by science and technology. So this didn't happen in one day, and we know that nothing happens in one day. You start a conversation, and slowly there is an invention, there is some developments that usually take place in context where there are people with the same interest, and there are a lot of tinkering and gadgeting and bringing materials and devices and machines. And this is what happened at CERN from the beginning. We are here in the 50s. This is the first image where you see these two scientists considering a way to detect cosmic rays with the materials that we had in the 50s and the 60s. And by being together, exploring these possibilities, these scientists saw something in nature that was never realized in the material at the time. There were many models represented in mathematical codes, language, but these cosmic rays that are forces, well, elements in our nature, were never described with an image. So how can we tell the story about these signals in nature without an image? This was quite impossible. So in the 50s, we had that image, thanks to something that was happening next to Geneva, 20 minutes from the Geneva Lake. So what you see in these images is crucial for the history of science and technology in the 21st century. Without that, we would not be able to have a mobile phone. What you have in your hands, in your pocket, is a particle detector. And this image is a detection of a particle with the old machines that were in the 50s, 60s, and later in the 70s. And these are prints. They are printed in paper, and there were people doing analysis of data out of these pictures. So these are the roots of science as we know it today. People like her were data analysts. And they were doing this with machines that were not coming from a factory, or devices that, like a joystick or a computer or a program. All of this was invented in a laboratory like CERN. And one might wonder today how this has happened in the last 67 years, and how this has affected everything we do today: communications, understanding our planet and the satellites and how information is taken from one place to the other, understanding the use of the waves, the electromagnetic signals, clocks, time, atomic clocks. Everything has been transformed in the last 60 some more years. And this is thanks to fundamental science, and it's very important for us to realize. Of course, at CERN, artists and any visitor who spend time with us see this picture in the 21st century. But it is not very different. We still see hundreds of people developing machines today, and this materiality of science is something that we kind of forget. And I love to go to the archives of CERN and see these images of people just devising and understanding how with an old machine you can do so much. And I saw computers like the ones we have at CERN here in the mid, which is really interesting. So this is a very important part of my story, and there is a philosopher of science and physicist, Peter Gallison, someone I always quote, and he has this very important book called Image and Experiment. He is in Harvard, and he says something that about this transformation of the laboratory, how he was so excited to know in the 70s how a laboratory became a place for electronics, gases, cryogenics, a place full of pipes and cables and connections between devices, and how this was becoming a very rapid development to describe nature as we know it today. Describe a part of nature that exists everywhere, and this is matter. So particle physicists at CERN are oriented to respond to a very big question, which is, what is the beginning of the universe? What happened in the Big Bang? But the very concrete question is, what is everything made of? What is matter? What are the forces inside matter? And matter is everything, it's us, it's everything we see. And these people created these massive machines that we know today, as the Large Hadron Collider and many others, to understand what is the stuff that we touch, we see, we are made of. So these images, of course, bring us this melancholy of the techno-science in the 70s and 80s. We are moving in time, but still are very relevant. There is a significance here in our society that is really important to me. So we are moving into these decades of development, and there is this moment in when computers have this shape. And computers are, of course, collecting this massive amount of data that is becoming almost impossible to describe or even to analyze, to distribute. So how do you share this data among your community so you can compute it better? And as many of you know, there is this moment 34 years ago when Tim Berners-Lee gives a protocol for management of data to his supervisor, and the World Wide Web starts at CERN in Switzerland. So this has happened in an environment of open science, and an environment where everyone could use this invention. And it's an invention that started to run an amazing design. Many gurus of technology say that never stopped running, was perfect, and still amaze many, many computer designers. And how this protocol of management of data is still running, and we can still use it. And it's obvious, well, to say that it has transformed our society. So this, I like to emphasize the fact that the World Wide Web started in an environment of open science for everyone. So I'm telling you all of this because there is a moment in when artists start to be very interested in what was happening there. But interested in everything. As Peter Gallison said, he was provoked by the question of the invention of a machine that through the gases tell us what is coming through our atmosphere, something that we don't see. So people like her devised these wheels that are filled with these little tubes and with a coil inside and with gases. And these tubes help scientists, still today, to determine when cosmic rays or a concrete particle stops there and show us what might have happened billions of years before in the universe. So this, of course, has the big conclusion. In the 2000s, we had, well, some pioneering minds came together and said, let's build the accelerator. So we know enough how we can create the fastest, coldest, the most hyperbolic machine on Earth to understand the primordial matter. And this is the Large Hadron Collider. This is an almost mythical machine, iconic, that we often show. And we could be said, hey, you are always with this big machine, big science, da-da-da. But it's true that it's a mythical machine because it's very difficult to see. It's very difficult to visit. It's 100 meters underground. It is only open for well, managing or fixing stuff once per year. And it's only open for very special visitors, not normal visitors, every 6 years. So the Large Hadron Collider is the fastest because it's imitating with the technology that we have today, the beginning or the second after the Big Bang. It's colliding matter, particles, that clash and are crushed in what we call collision events. And these particles give us more matter, matter that might not exist in the universe unless you create it. And with that, we have right now 10,000 people at CERN working to understand what is happening in this very moment of when these particles collide. So this, well, some description that you might know. The Large Hadron Collider is the biggest machine ever built by humans, and is in a tunnel 100 meters underground, and is a big circumference of 27 kilometers. It goes from the Meran site next to Geneva in Switzerland, next to move towards the Jura Mountains into France. So CERN is also occupying 2 countries. And it's important to say that CERN is the laboratory, the only laboratory that existed in the 20th century created as an interstatal organization and as an international collaboration, and it's still running today. So just to tell you that there is no universities, there is no teaching, but if you want to be an accelerator physicist, you need to come here and work in the Large Hadron Collider. So I continue, so I move from history to the concrete reality of these machines today to stopping a very fundamental idea. And I often reflect on that when I go to see these machines, because I have the privilege to bring artists into these detectors. So the Large Hadron Collider has 4 machines of this kind. They are called particle detectors. These are really big cameras that take the picture of these big collision events that I mentioned before. But these machines are, each of them are a prototype. They are being renewed and rebuilt and upgraded all the time with the latest technology, the latest development in science. So in a way, if we take the analogy of life sciences, we have a big petri dish here where life is moving and is dynamic and is in fluxus. So it's full of analogies and it's full of flavors. You can do many things with these ideas. And when we bring artists at CERN, it's a very fertile place for ideas. You see, this is another detector. And this is really what they want to get, the standard model of physics. So this is the context in which my program happens. But it didn't start in one day, as I said before, because everything is moving, everything is passing, and we have these new machines like the neutrino detector that is being built at CERN. But I often think that with all these machines, we have these brothers and sisters as machines deployed in the whole planet to sense our nature, to understand our nature. And an important idea that some artists come with, and this is a very important question in contemporary art today, is the scale of humans, how tiny we are compared to the knowledge we have, or the knowledge that we think we have. And these complex systems of machines deployed around the planet that are looking for very exotic things like black holes colliding or merging into each other, or galaxies that are so far that not even light gets there, or events that are so rare as to see as gravitational waves. And we are reading and listening to this every day in the media. So when we read that in the media, it's already translated for us. It's translated. The places where these machines are deployed are usually very remote. They could feel a bit like fairy tales to us, but it's clear and tangible reality. So this is the ice cube in the Antarctic. It's a neutrino detector. And before I show you the antennas, the radio telescopes in the Atacama Desert in Chile. Before I show you the neutrino detector and the Large Hadron Collider, what a collection of machines. Huh? And the data that is being created here is extraordinary. And we are, well, the Hubble, we are tiny humans looking at nature, and it's becoming bigger and bigger thanks to this. So let's go back to the artist. In 1973, the year I was born, James Lee Bayer came to CERN when CERN was just a working site, as you see, very different to today. And he said, hey, I want to understand what you are doing, but just by intuition, don't explain me too much. I just want to be here in the place where the Big Bang is going to be described. James Lee Byers was involved in the Fluxus movement, and he saw himself as an artwork, an art. Art and life was so close in his oeuvre. And the most extraordinary thing to me to find when I arrived to CERN and to dig in the archives was to see him in the CERN Courier, in the front page. He was the one and only artist in the CERN Courier in the 1973, a very progressive time when artists were in labs at that time. And if you see in the credits of the photograph, says, one of the visitors who brought some color into the CERN corridors during the summer. He is photographed here in the ISR site with the experimental hall and water tower in the background. So James Lee Byers came back several times. I think a scientist opened the door to him because he was, he brought some color. But it's important to say that art and science has existed always. Every time there is a place with some mystery or some surprise or even some banal information, you have an artist there. We are not inventing anything. They are pioneers and experimenters. And where the experiment is, there is an artist. Later in 2005, Gianni Motti, a Swiss artist from Geneva, walked through the tunnel to challenge the possibility of becoming the anti-Motti. So if he walked fast enough, he could annihilate himself and become part of something that was antimatter, anti-Motti. So he walked for hours inside the tunnel, a tunnel of the Large Hadron Collider, which was still empty. The machine was not deployed yet. And this is one of the first artworks, the first art commissions that we supported. In 2011, 2012, we had this great moment of discovery of the Higgs boson, and our director at the time said, we've been having artists, John Berger, Amsel Kiefer, Anthony Homley, so many artists, Gianni Motti, James Lee Byers. We had a big list of artists. Why don't we start a program? Art and science are always creating new realities, right? So let's support this. And thanks to that, the Arts at CERN started as the official program of CERN. And it's not only an artistic residency, it's the arts program. We have a CERN cultural policy. We have a cultural board, we open programs, strategies, and most of all, we listen to our community. We try to understand what we are doing. We don't do communication of science, but we understand the impact of doing something like this in the understanding, being informed, having a closer relation with science and technology through the arts. So here you have a semiconductor. They are John Gerard and Ruth Jarman, a couple from Brighton. They came for a residency of 3 months in 2015, and the following years they kept doing new work. They are with Daniel Figueroa, a cosmologist who was with us at the time. Now he is in Valencia. And this session that you are seeing here is something very common. We see it. There is this information exchange. There is a lot to learn, to understand about the scientists' works, and the realization that what is happening in the labs is not what we think of science. Everything is doing something new all the time. It's from scratch. So I'm going to play a very important artwork for us. It was one of the first commissions that we did. And it's a work by Semiconductor. It's called The View from Nowhere. And I'm not going to play all of it because it's an artwork. You should see it in an art gallery. But it will tell you a lot about what they saw in the lab.
There is a human viewpoint, because we are a few billion individuals sitting on some rock, going around some nondescript star in a nondescript galaxy. Every once in a while you think, holy fuck, there's 10 to the 11 stars in our galaxy, and presumably even more planets, and there's 10 to the 11 galaxies. So what else is happening out there that we can't yet see? There certainly is a particularity to the way we do our science, which is enforced by the resources that we have available. How much sunlight falls on the Earth and how big the Earth is.
Well, I was daydreaming with a lot of mathematics. It's like the process of creation, right? When you try to create something new, you do some doodling, you play here, you play there, you do a little computation here, a little computation there, listen to talks, read papers. I mean, it's like artists get inspiration. It's hard to tell where it comes from. You have to think in a creative way, but with rigor at some point. You have to have some logical rigor. Sometimes you only have, for example, the satisfaction of solving a riddle. So that's when, for example, string theory and some of these other theories, all of a sudden you got more or less the right answer, or an answer that looks right. And that's very intriguing. There, of course, these are things which are conceptual developments and conceptual breakthroughs. And you hope that these conceptual breakthroughs eventually will lead to something that could be tested in nature. The first thing that you do is try to get a mathematical model in your head, something you can work with. I don't need to do it in paper. So you can think in this kind of a mixture between what you experience and this very abstract mathematical world. Is the place where I can pose the questions. I don't think in terms of words. So these are non-verbal images or non-visual images. So you look, for example, at quantum mechanics. You can look at experiments, you can get some pictures, but most of the pictures and the metaphors are wrong or are misleading. That's where the mathematics comes very, very handy. So then I already have in my mind a collection of formulas from general relativity. So you have to, rewire your brain a little bit.
Science doesn't change reality. What I happen to think is a particularly powerful and effective way of interpreting reality so that you can actually do something with whatever understanding you have. What we're trying to do is to assemble all the constraints coming from all sorts of different experiments within a specific theoretical framework. We're also trying to find, if you like, the soft underbelly of the theory.
Well, nature also has contributed quite a bit because, as you look at the interactions, they can be described with fairly well-structured symmetries. Why is that? Nobody knows. We have this framework of understanding the world, and perhaps we've reached the limit of this particular language. We need something else. Anything in physics can be described with three dimensions, which is length, time, and mass. So you try to use the units that are important to describe things. So, for example, you're talking about humans, you talk about in meters, you don't talk in angstroms. You look at water coming out of a faucet. If you take, a frames every few nanoseconds, you will not understand what you see. You would have to really relearn the world at that speed. Nothing flows. There are no liquids, no continuity. Everything is atomized in such a way that it's hard to understand what's going on. It's all random. It's not less realistic at all. It's the same world. It's that we are sampling it at a different pace. So you have to always, sometimes using the right units opens up your eyes. It's stupid. But that's, again, that's the way our brain perceives things.
We can leave it there. So in the view from nowhere is a term from anthropology in which you look at something without interfering, and it's part of a methodology. They wanted to employ this methodology at CERN, understanding that they were seeing something that was contradictory. So they were seeing, during the 3 months of the residency, they were seeing people modeling the world through ideas, mathematics. And they have been doing this since Max Planck, the quantum mechanics, and this modeling the world through mathematics is accumulating. But in parallel, they saw many people working with machines, developing these devices with a precision and a complexity that I only can imagine in watchmaking. And the development of materials brought them to realize that there was a description of nature that was made only thanks to these processes. And this triggered many questions in their artistic practice. So they invited two people, Luis Álvarez Gaume and John Ellis, two theoretical physicists, senior physicists, really respected, working mostly in string theory, to talk about their work. And while they are talking, we are seeing this materiality, the raw material, the devising, the warehouses full of tubes and materials that might refer to us like, a car factory, but with a precision of, the best master watchmaker. And later, I worked with them again in the Art Basel Commission for Audemars Piguet, and we had the opportunity to work with watchmakers. And there was the realization that they were doing the same. They were creating big clocks to understand the beginning and the end of the universe with machines that have the power at the most advanced level in in science today. So I think this was only one of the three works that Semiconductor developed during the residency. The three of them are very different. This was the view from nowhere, looking without interfering. But then they became really interested in something that I'm going to show you, that is the actual mechanics of a machine that could be something like this, which is a machine that we have at CERN that is suing superconducting material, which is a very rare material in nature. Or these all devices that you saw in my first slide, that are conducting light to understand what is happening in this phenomena, in the photons. And together we built something new. With the support of Audemars Piguet, one of the most important houses of watchmaking in Switzerland, we invite them to develop a new work that was almost impossible to develop unless we had this kind of support, in which they wanted to understand this heavy machinery development, or this design development, this invention, with the understanding of data analysis from these machines. Because while scientists are doing all these machines, then later get the data, and you need to understand the data and construct the data and make a new language out of it. So with the Audemars Piguet Arts Commission, which was shown in Basel in 2018, the artists developed a vertical piano with 346 strings, as high as 4 meters, in which there is a data visualization They spent 2 years working with scientists, with raw data to create this visualization. And every time a light pulls one of the strings, the piano plays something that is far from a melody, but is an acoustic piano that is running in real time in the gallery. As you see, there is immersion. These data points that you saw in the view from nowhere, were part of this huge exercise of constructing, understanding, modeling the data in a visual language with the scientists, with the support of the scientists. And this is the heavy development that they did with designers to create this work that was only shown 3 times before the pandemic started. And this, well, is one of the big masterpieces of art and physics. And you might remember before that I had one device. I show a slide of a woman building this device. We had the opportunity in this exhibition to bring one of the part of the detectors of the experiment to Art Basel, and many people ask if this was a sculpture, because I love to see how people work at CERN, but they are really sculpturing things that are not made in industry. So it was good to bring a bit of science to Art Basel. So, of course, I show you this because it's only one of many interpretations or manifestations of art from CERN. There are many people who do not take this approach. There are many people who tell stories, as I like to do. Many people who work with sound. They forget about materiality. Many people working with the community, understanding how the community, a community of 10,000 people, share the invention of these machines and what it means to do them. And there are many people who are interested in data, in picturing the experiment as well, but without becoming involved in this hands-on contribution through the arts. What is really brilliant aspect of CERN is that the history of science in Europe is there contained, many elements and components that no one look, only the artists go into the archives. And I was talking earlier with Maria of the importance of the archives, understanding where things are coming from, but also how they are still affecting us, not from a linear time perspective, but this accumulation of experiences is still with us, even when we were not part of it. And the images, what is an image today is something very important, very relevant, and there are many artists dealing with this question. One artist, Armin Linke, from an Italian-German artist, is dealing with this question, and there is a really interesting exhibition of him in the MAST in Bologna. If you have the chance to go, there are many of, there is a contribution of us in this exhibition. And then there are other artists that are dealing with the actual machinery, and the pavilion, the Korean pavilion in the Venice Biennale, if you had the chance to go, is inspired by the CERN science. The artist Jun Chul Kim came to spend time with us, and he is working with actual particle detectors that he builds. This is one. It's a muon detector. It's really using Geiger tubes, and he devised everything with his own expertise. His studio is like a physics and chemistry laboratory. Go to see it if you can. And the Venice Biennale closes in 2 weeks, I think. But it's really beautiful. And this is part of his work as well that we curated for the exhibition in the CCCB in Barcelona. And then we have this amazing program that I love and I always forget to talk about. But I realized the potential and the importance of bringing science into the arts and vice versa. So creating a culture. Science is culture. Science is a pillar of our society. And from a cultural perspective, we need to acknowledge this. So Cecilia Vicuña here is a Chilean artist. And we work with the Centro Cultural de España in Chile and the consulate there to bring her to CERN. But because she was before in the observatories in Chile. So she was present in these different ways to look at nature, which was through telescopes, radio telescopes, and optical telescopes. And she wanted to have this counterpart, the subatomic matter, what that means. She's a poet and a visual artist. So she is creating a transcendental poetic materiality work that, we think she has been inspired. There is not an art commission, but her work is really cosmos-oriented and was only natural for us to support her research on that. So research is very important for us. Research and going to remote locations that don't need to be in Chile, but sometimes they are. And we have a collaboration with Chile, South Africa, India, and Australia that allows artists to come to CERN for a few weeks and then go to these places with usually astronomers or cosmologists. So international collaboration through the arts is very important because we understand that science gives us this opportunity and art is obviously part of it. So we had an exhibition Quantica that toured in Europe in different places before the pandemic stopped it, called Quantica. And this is in the CCCB. We managed to bring this polyedric view into art and science, what means for us being and how are we being affected from different angles. Scientific diplomacy, using domestic stuff that is being built in laboratories and many other things in art and design that are important. So I think I talked too much, maybe. So I'm going to leave it here with these really nice and smiley people, Alan Bogana, Nicole Lullier, and Melissa. They work with us, and she is part of my team. And I'm going to finish with something Nicole Lullier did, an exercise in the Alice detector where she puts together this machine of poetry that she built to run in the experiment while there are some visitors in the experiment. So this is the last slide. Thank you very much. Enjoy it. Thank you.
Right.